This is a solution to example 4a from notes P.5, where we're simplifying a complex fraction. Here we're going to use a method where we're going to multiply by a funny form of 1, but in this case the funny form of 1 is going to be the least common denominator of all the denominators divided by the least common denominator of all the denominators. This method will clear out the fractions, and sometimes it's easier to use than the method where we first simplify the numerator and then simplify the denominator and then divide those fractions. So in this case, the LCD of all the denominators, I'm going to write that down, LCD of all the denominators, we actually have 4 denominators, y, 2y plus 1, y, and 1. So the LCD of all those denominators is y times 2y plus 1. So we're going to go ahead and we are going to multiply both everything by this least common denominator. So I'm going to multiply the numerator by y times 2y plus 1 over 1. And I'm going to multiply the denominator by y times the quantity 2y plus 1 over 1. And I'm writing each of those as fractions because both the numerator and the denominators are fractions. Now we're going to go ahead and do this multiplication. All right, so I'm going to distribute y times 2y plus 1 to my first fraction, which is 5 over y. When I do that, I'm going to write this out the long way here. If you were simplifying this way, I would not expect you to write this out. So I'm going to have y times 2y plus 1 divided by 1 times 5 over y. And then I'm going to go ahead and distribute the same factor to the 6 over 2y plus 1. So I'm going to have minus y times 2y plus 1 over 1 times 6 over 2y plus 1. And then in the denominator, I'm going to do the same thing. So I'm going to have y times the quantity 2y plus 1 over 1 times 5 over y. And then plus y times 2y plus 1 over 1 times 4 over 1. And what you're going to see now is something really nice happens, and that's all the fractions are going to clear. So let's go back to the numerator. So when we multiply y times 2y plus 1 times 5 over y, the y's cancel out. Going to the next term in the numerator over here, I'm going to cancel out common factor. Here it's 2y plus 1. That's going to cancel out. And I'm going to go look at the denominator. Look at the first fraction in the denominator. The y's cancel out. And in the second fraction, there's nothing to cancel out. Okay, because I just have denominators of 1 here. And now let's simplify the numerator. So the numerator is 5 times 2y plus 1 minus 6y. And now the denominator is 5 times 2y plus 1 plus 4y times 2y plus 1. And you'll see the complex fraction is gone now. I'm going to keep simplifying here. So the numerator, I can distribute the 5 to the 2y plus 1. So I'm going to get 10y plus 5 minus 6y. The denominator, I'm actually going to factor this to see if maybe I can get a term to cancel out. And if you look here, both of these terms have a common factor of 2y plus 1. So this is like when we factor by grouping. So we actually have 2y plus 1, and when we factor that out, we're going to be left with 5 from the first term and 4y from the second term. And I am going to write that as 4y plus 5. And then when we combine like terms in the numerator, we're going to get 4y plus 5, subtracting 6y from 10y, over 2y plus 1 times 4y plus 5. The 4y plus 5 divides out, leaving us with 1 divided by 2y plus 1. And then we need to list values that were excluded from the original function, which we can no longer see because we canceled out factors. And when we simplify it, so we're going to say y, 1 over 2y plus 1, where y is not equal to, and let's figure out what y is not equal to. We canceled out this 4y plus 5, so we have to exclude the value that made 4y plus 5 equal to 0. So we're going to solve 4y plus 5 is not equal to 0. So 4y subtracting 5 from both sides is not equal to negative 5. Dividing both sides by 4, we'll get y is not equal to negative 5/4. I'll list that. The second value we need to exclude is y is not equal to 0. So I'm going to list that too. And the reason we need to exclude that is in the original expression way up here, we had y equal to, y in the denominator. And if y is in the denominator in the original function, that means y cannot be equal to 0 in the simplified expression. And when we look at the simplified expression, we no longer have y in any denominator. If we're going to specify the domain, we actually have to list one more value to be excluded. So the domain is going to be all real numbers. And we're going to list these two values that we had before, which were negative 5/4 and 0. But there's actually a third value. And that third value comes from the 2y plus 1. That's actually still in the simplified expression. But for domain, we need to be specific and list all values that are excluded. So we're going to figure out what value is excluded from having 2y plus 1 in the denominator. So we write 2y plus 1 is not equal to 0. So 2y is not equal to negative 1, subtracting 1 from both sides. Dividing both sides by 2, we'll get y is not equal to negative 1/2. And I'm going to list that as a third value that is excluded from the domain. So we're going to have negative 1/2. So the domain is all real numbers except negative 5/4, 0, and negative 1/2.